Now we have discussed what is resistance and what is electric current, okay, and what is the cause of this electric current. Basically the potential difference across the ends of a conductor that constitutes the electric current, okay. Now in a circuit, when we check about these factors, so what is the relation between the potential difference and the electric current through a conductor, okay. We will take the example of a simple electric circuit, something like this, okay. I have a cell over here, okay, and then I have a resistor. Resistor is something which offers resistance, okay, and I'll have an ammeter over here, A plus minus, and then across this I'll connect voltmeter, okay, and then here I have a plug key connected, and then that's it, okay. So what I can do is, like, I can have a battery over here, and then connect my terminal or across any other 2 points, okay. What I am doing is, I am not directly connecting here these two terminals. What I am doing is, I am taking this wire and inserting in between. Like a variable resistor will have a arrow mark like this. This is a variable battery. So I wanted to change the battery value over here, the voltage. Check the potential difference across this resistor, say R, this particular endpoint, say XY. Okay, I wanted to check out every time the current passing through the conductor, so this particular part. So I am fixing an ammeter in between, and across the terminals, voltmeter is always connected across the terminals. So I am connecting the voltmeter across this resistor XY, and then I have a key over here where I can switch it on and off, okay, this way. This is on. If I don't having this dot over here, that is off. So this is a circuit diagram. What I wish to do is, first initially I'll switch it off. I'll put it in off position, connect over here. So one cell is connected, okay. So one cell is connected and then switch it on. I'll take the measurements in both voltmeter and ammeter. So I will take over here, say serial number. It may be referring to the number of cells connected. So I have one cell connected, 1. Then I will take out the voltmeter reading. Okay, I will take the ammeter reading. Now this ammeter and voltmeter, so ammeter measures the current in amps. So 1 ampere is a bigger unit, okay, very bigger unit. So I will try to connect a milliammeter or a microammeter. Milli is 10 power minus 3 amps. Okay, milli means 10 power minus 3. So I will take a milliammeter or a microammeter. Similarly, I will take a millivoltmeter over here. Okay, so which are measuring small amounts of potential difference, or I can take a voltmeter and then I will take a milliammeter. 1 amps is very large quantity. So maybe this is measured in volt. This is in milliamps, MA. M in the lower case stands for milli, and then I'll check out what are the values in it every time. So I'll have one cell connected across. I'll take the readings in the voltmeter and this milliammeter over here. So let us assume, it's an assumption, let us assume I have a 0.5 volt, okay, and I have 20 milliamps, okay. Then what I'll do is, I'll take this connection over here and then connect this point over here, this point here. That means now I am having two cells. Let us say instead of having 0.5, I'll say 1.5 in the first case. So for each cell 1.5 volt, now I am taking two cells. So 1.5 plus 1.5, I'll have 3.0 volts. Okay. Then again I'll try to switch on and then check the voltmeter. This is 3 volt across this particular XY resistor, and then I'll try to measure over here. This is 40 amps, 40 milliamps. Okay. Like this, I'll again disconnect over here and connect this end over this particular point. That means I have 3 cells connected in between. Okay, 3 cells. Now I have 3 cells. It is say 4.5 volt. Each one 1.5. I have connected them side by side so that the positive end of one cell is connected to the negative end of the other cell. This way I have connected. Okay. So every time I am increasing by 1.5 volt. Now I'll try to, so every time I try to change over here, what should I do is, I should first switch off the circuit over here, then change the connection and then switch it on. So then I'll take the readings, voltmeter and ammeter. So what should be the value over here? Approximately say 60 milliamps. So similarly, if I disconnect it here, switch it off, disconnect it over here, and then directly connect this point over here. That means now I have 4 cells in connection. So it will be 6.0 volt. Okay, this will be 80 milliamps. So every time if I consider this way. So when I try to find out, so instead of A, I can write it as I. I stands for current, ammeter reading. So it is taken in milliamps. So now what I'll do is, let us say this is milliammeter, this is voltmeter. I am measuring the current in the milliammeter and then potential difference across this particular point in the voltmeter. Now what I'll do is, I'll plot a graph between what I am changing here on my own is battery. According to the battery changing positions over here, I am increasing the potential difference. So this potential difference is what I am changing on my wish. So I will take the potential difference across the x-axis. And what I am measuring, this one, this is a dependent quantity. Okay, so electric current, I will take it along the y-axis. This is in volt and this is in milliamps. When I try to plot all these points, and what I am going to get is like, so the points are like this. So when I draw a straight line, I will be getting a straight line passing through the origin. So this is one point, second point, third point, fourth point, like this. What does this mean actually? That means that whenever I am increasing the potential difference according to the current is increasing, electric current is increasing. So I will say that electric current is directly proportional to the potential difference. I can say I is proportional to V, or I is equal to some constant K into V. Okay. So or else I can write V is equal to some constant K dash into I. This is a constant. This constant is different, this constant is different. Okay. Or else from this I can say V is proportional to I anyway. So there is a, even though they appear to be the same, when I say I proportional to V and V proportional to I, they appear to be the same, but innerly the meaning is different. When I say I proportional to V, okay, I mean to say that this I depends on V. When V changes, I changes. I is dependent on V. Okay. When I say V proportional to I mean to say V is dependent on I. So actually it is the other way around. Okay. So from this expression I can write I is equal to some constant k into V. When I change the terms, I can say V is equal to some constant k dash into I. From this, I can say this V is proportional to I. Actually speaking, it is I proportional to V. So this V proportional to I or V is equal to some constant k into I. This constant k dash is nothing but the ratio between V and I. So this particular thing, I will write this as V is equal to I into R. This R is nothing but resistance. This constant k dash is nothing but R, that resistance. This is the electrical resistance of this resistor. Resistor is the device or the item. Okay, resistance is the property. Okay, so this V is equal to IR, what do you call it as? Ohm's law. This is what you call Ohm's law. So according to Ohm's law, the electric current through a conductor is dependent on its potential difference across its ends. Okay, so when I say V is equal to IR, R is a resistance. To measure the resistance, I take the symbol R is equal to V by I. This is the expression from this. So R is measured in ohm based on the name of the scientist who has devised this one. So if I take here R is equal to V by I, every time I measure now V by I, V is 1.5, 1.5 by 20. So 1.5 divided by 20 milliamps. So I will take 20 into 10 power minus 3. Here if I take, it is 3.0 divided by 40 into 10 power minus 3. So the ratio will be the same if you consider. It is 1.5 by 20 into 10 power minus 3 or 3 by 4 into 10 power minus 3, whatever it is. So it will become here 4.5 divided by 60 into 10 power minus 3, or here I can say 6.0 divided by 80 into 10 power minus 3. In all these cases, I will have a constant value which is approximately 75,000 or 7500. So it is 3 by 4, 3/4 is 0.75, 0.75 to 10 power 2. So it is 75. Okay, so approximately I will get this value as 75 ohm. So this is the symbol for its unit. So 1 ohm is equal to 1 volt by 1 ampere. So in terms of units, if you consider 1 ohm is equal to 1 volt by 1 ampere. So this is the very important law called Ohm's law. According to Ohm's law, the current through a conductor is proportional to the potential difference across its ends. Okay, and the ratio of the potential difference to the conductor electric current through a conductor is equal to the resistance of the conductor. Okay, so for good conductors, the value of resistance is very, very small. Okay, like gold, silver or any metal you consider, the value of resistance is very, very small. And for insulators, the value of resistance is very high. So electrical insulators basically like glass, wool, wood, okay, and something like rubber, all these materials, they have very high resistance values. Porcelain, ceramic, etc. So this is about Ohm's law.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.